Hi students, I hope everyone has revised all the previous topics which we were studying. Now the next topic which we need to cover in electrochemistry is your electrode potential. Next topic which we need to cover is your electrode potential. Now what is an electrode potential? We'll define it by a diagram. Okay. Electrode potential is a numerical value. Okay, just remember this is a numerical value. What is the potential of zinc electrode? Sometimes I tell. So it is measured in volt. Potential is measured in volt, right? So electrode potential will also be measured in volt. Now what is actually electrode potential? I'll tell you. Suppose you have an apparatus that undergoes oxidation. The electrode of this apparatus undergo oxidation. What happens in oxidation? Oxidation is actually the loss of electrons, right? Oxidation means loss of electrons. Loss of electrons. So supposingly I have a metal M. Like this is an electrode made up of metal M. Oxidation happens. It loses suppose N electrons. N electrons, right? So this metal, supposingly if it is zinc, so zinc has lost 2 electrons and these electrons comes in the solution, correct? Like how we did in the electrochemical cell. So can you see that here you will have zinc and in the solution you will be having Zn2 plus the ions. There is a charge separation, correct, between the zinc as well as its ion. So this charge separation between the metal, that is between the electrode which is your metal and its ions. Where are its ions? In the electrolyte, right? And its ions, electrolyte, under equilibrium. Just remember this term, under equilibrium. Equilibrium topic will study later on. Just remember for now, under equilibrium is called as electrode potential. I'll repeat it again. Like if you have a apparatus, a metal which undergoes oxidation, so the metal is attached to the electrode and it loses electrons because here the oxidation is happening. So it's losing electrons. It's becoming Zn2 plus. So this kind of charge separation between this metal and the ion, between the metal and the electrolyte, electrode and the electrolyte is called as your electrode potential. The charge separation, it's basically a charge separation. Now since here your oxidation is happening, you will be calling this particular thing as oxidation electrode potential. You will be calling this as oxidative electrode potential. Okay. Now exactly if the reverse thing happens, just remember that we did it in our last concept, how the reduction happens in copper. What was happening in copper? The copper from the solution was coming and attaching at the electrode. So you were getting copper. Like reduction was happening, right? Reduction means gain of electrons. So when this happens, this charge separation between the ion, same thing only, between the ion and the electrolyte, between the metal and its ion is called as electrode potential. But in this case, it will be called as reductive electrode potential or reduction electrode potential. So this is what your electrode potential is all about. It's basically your charge separation between the metal and its electrolyte. Okay. Now there is one more thing which you should remember is your inert electrode. one more thing which you should remember is your inert electrode. What is your inert electrode? Inert electrode is something which does not react. What do you mean by inert? Inert means it's hidden. It's not reacting. It's not reacting with any of the solution. It's not giving any oxidation, any reduction. So example is platinum, graphite. Whenever you have such kind of electrode, it means they are inert electrode. Platinum, graphite, etc., which do not undergo oxidation or reduction, are called as inert electrode. Which do not undergo oxidation or reduction is called as inert electrode. Okay, so understood what is an electrode potential? The charge separation between the metal, that is your electrode, and its electrolyte, that is your ions, is called as your electrode potential. It is measured in the unit of volt. Potential is measured in volt, right? And it can be of two kinds: oxidation reduction potential and reduction electrode potential. Now there are some things called as factors affecting electrode potential. You have the next topic as factors affecting electrode potential. Factors affecting electrode potential. Now what all will be the factors here? The first factor will be obviously nature of electrode, nature of metal and its ion, or you can just tell is nature of electrode, nature of metal and its ion. See, electrode potential is any numerical value, right? So it depends upon what metal you are using. On that only the numerical value will differ. Like suppose if you are using zinc, zinc is giving you Zn2 plus ions. If you are using iron, iron is giving you Fe2 plus ions. Iron sometimes gives Fe3 plus ions also. So all the electrode value depends upon what metal you are using. Now since the metal is metal and its ion. Now since here you can check, metal is same but its ion is different, right? So your electrode potential value will also be different. This is your first factor. The second factor is your concentration. All this thing will be studying more in detail in Nernst equation. Next is your concentration of ions. Concentration of ions. Concentration we usually write in square brackets, Mn plus. So depends upon the concentration of ions also. In case of gases, we take partial pressure. In case of gases, we take partial pressure. The third factor on which your electrode potential differs is your temperature. Based on what temperature value it has, the electrode potential might differ. Okay, so till now we have studied the definition of electrode potential. What is an electrode potential? It is just the charge separation between your metal and your ions. That is your electrode potential. It's a numerical value and you measure it in the unit of volts. And also we have seen the factors affecting electrode potential, the nature of metal, the concentration and temperature. The factors you will be more familiar with it in the Nernst equation. Now this electrode potential, there are two kinds of electrode potential. When you talk about electrode potential, there are basically two kinds of electrode potential. The first one is called as standard electrode potential. The first one is called as standard electrode potential, which is measured as E naught. Like this is represented as E naught. Naught means just a sign, like just a circle over your E. That's your naught, standard electrode potential. The next kind of electrode potential is your simple electrode potential. And this is represented by E. This is represented by your E. Now, what do you mean by standard electrode potential? Something is standardized, something is fixed. That's why it is called a standard electrode potential. So this value never changes in any condition. No factors affects this thing. Never changes. Standard electrode potential, you can write, never changes. And some things are standard, right? And what all things will be standard here? The first thing which is standard is your concentration. The first thing which is standard here is your concentration. The concentration means the concentration of electrolyte, which is your 1m, always in 1 molar. The second thing which doesn't change is your pressure. If you're taking a gas, the pressure is also 1 atm per bar. And the temperature also. The temperature is also fixed here, which is your 298 Kelvin, which is your 25 degrees Celsius. These three things are fixed. Whenever these three, suppose I give you an electrode, like just calculate the standard electrode potential of the zinc. If I give you a zinc electrode, so how will you calculate the zinc electrode potential? When the ions are in concentration of 1m, the pressure of the gas, if in case of any gas is present, is 1 atm, and the temperature is 25 degrees Celsius, then only you can calculate the standard electrode potential. Like this is already known for all the metals, because they have already calculated all these things. Now the electrode potential is something which changes. How it changes? Like, how do we calculate electrode potential? From your Nernst equation. In different conditions it changes, and from your Nernst equation we can calculate the electrode potential. Okay, and this definitely depends upon many factors like your temperature, your concentration, everything depends upon this. But here in standard electrode potential we have fixed certain things. Okay, so like this, like you all know that electrode potential we calculated in two particular things. Electrode potential we calculated, like two things were there, right? First was oxidation reduction potential, oxidation electrode potential, and the second one which we were studying was reduction electrode potential. Reduction electrode potential, right? So what is oxidation? Oxidation is loss of electrons, right? I'm writing an equation. M metal loses your n electrons. This is what your oxidation is. N electrons, right? What is reduction? Suppose your X metal which has its ion accepts electron. Reduction is accepting of electron to give you X metal. That is your reduction potential, right? Then we studied about two electrode potential. One is standardized, one is fixed, and the other one which we need to measure by the Nernst equation. First electrode potential was standard electrode potential, which is measured as E naught. Correct? E naught. Now we are measuring oxidation electrode potential, standard oxidation potential. So how will we write it down? M is converting into Mn plus. That's what your oxidation is, right? This is how you mention standard oxidative electrode potential. How do we write normal electrode potential? Normal oxidation electrode potential. E, M is converting into Mn plus. This is how you identify that this is your oxidation happening. So this is your oxidation electrode potential. Similarly, pause this video and try for reduction electrode potential. How will you mention standard reduction potential and reduction electrode potential? So you can see here, standard we write E naught. Now since reduction is happening, whatever is present on the left hand side, ion, that you write first, Xn plus, put a slash, what is happening in the end, what are you getting? X. So this is your standard reduction oxidation, reduction electrode potential. This is your standard reduction electrode potential. And how will you write reduction electrode potential? Simply this metal is converting into X. This is your reduction electrode potential. Clear? So just a quick revision. What is first you need to start? What is an electrode potential? Electrode potential is nothing but the charge separation between your two things, your metal and your electrolyte, right? Now two things happens, oxidation also happens, reduction also happens. So based on that you can get oxidation reduction potential, reduction electrode potential. Then there are two more things. Electrode potential can be of two kinds, E naught and E. E naught is standard, E is something which you need to measure by Nernst equation. Nernst equation will be covered in the next topics. But standard electrode potential means the conditions are fixed. The concentration, the pressure, the temperature, everything is fixed, and then you measure the electrode potential. That is your standard electrode potential. So it can be standard oxidation potential also, standard reduction potential also. Similarly, if things are not fixed, you need to measure simple oxidation reduction potential, oxidation electrode potential, and your reduction electrode potential. Clear? So if you're not clear, try to watch the video from the starting so that it becomes more clear again and again. Now, a story time. Story time. Okay. Supposingly, I told someone, say I told a guy named Tom, that please tell me the electrode potential of zinc. So he's telling that electrode potential of zinc is 0.76 volt. Tom is telling my electrode potential of zinc is 0.76 volt. Now if I ask Sam, Sam is telling that no, electrode potential of zinc is minus 0.76 volt. Now what is this confusion? Like someone is telling me 0.76 volt, someone is telling me minus 0.76 volt. There is some kind of confusion, right? So this problem was actually solved by IUPAC. This solution was given by IUPAC. What did they tell us now? That whenever we are talking about your electrode potential, let us assume that you guys are talking about standard reduction potential only. So they told, let us assume your standard reduction potential is actually your electrode potential. Okay, so if someone is telling you, because there will occur a lot of confusion, right? Like if I have to mention standard oxidation potential also, standard reduction potential also, it will be a lot confusing. So IUPAC told that okay, let us fix one thing. Let us just fix your electrode potential as standard reduction potential. So from now on, whenever I tell electrode potential, it just means standard reduction potential. But what if in question only standard oxidation potential is given and they are telling you to find the standard electrode potential? What will you do? Just do one thing. Standard oxidation potential is standard reduction potential is just the negative of standard oxidation potential, right? So if I tell you, if I'm just writing this thing, I'm writing this thing, E naught of Zn and Zn2 plus is your 0.76 volt. So is this your electrode potential? Just find it out. How will you find it out? Just focus on this notation, Zn and Zn2 plus. What is happening here? Oxidation or reduction? Here your oxidation is happening, right? Because zinc is getting converted. Firstly, zinc is getting converted to Zn2 plus. Metal is converting into ions. Zn is converting into Zn2 plus 2 electrons. So here your oxidation is happening. So it means this is the value of standard oxidation potential. Now if you need to convert it into standard reduction potential, you just need to do the negative of it. So minus 0.76 will be your electrode potential. Got it? So we covered few things: electrode potential, standard reduction potential, and oxidation potential, and about the IUPAC nomenclature, like not nomenclature, IUPAC things, like what all they actually want. Okay. Now we'll see how to find the EMF of the cell. Next topic which we need to cover is your EMF of the cell. Electromotive force of the cell. Just check the definition on your own. It's very easy. Now how to find the EMF of the cell? I'll first write the formula. And how did this formula come? I'll tell you later. EMF of the cell is calculated as E of cell. E of cell is same thing only. E of cell is calculated as E of cathode minus E of anode. Obviously, both these sides we are taking the reduction potential. One minute, guys. I'll just be back, or we'll do the EMF of the cell and delta G later in the next video, so that it becomes more easy. Till then, please revise these, and let's continue from the next video. Thank you so much.